My name is JC Greco. I'm a freshman at Creighton University right now, and I'm here today to tell you about Zeno's 3 paradoxes of motion. These are 3 concepts that I learned about when I was in 8th grade, and I was just really fascinated by them because they employ really simple math topics, but they're also really fun and unique because just to give you a little introduction on what a paradox is before we begin, in case you don't know, a paradox is a statement that when I read it, it seems impossible, seems absurd, unreal, that it can't be true. However, then this statement can be explained using math or logic in a way that it appears to be true. So a statement which on its own seems impossible, but then we proceed to explain it in a way that makes it appear to be true. And so that's why a paradox is so confusing, because it makes you question the way that you think, the way that you see the world, and it makes you question what you originally thought to be true. And so that's what Zeno does for us in these 3 paradoxes of motion, is he gives us a statement and then we think it's wrong, and he explains to us that no, maybe your thinking is wrong. So it'll make more sense as we continue in the presentation. So a little background on Zeno of Elea. So he lived from 490 to 430 BC, so many, many centuries ago. And he was a famous Greek philosopher. And one interesting fact about him is that none of his work survived intact. And so that means that all of our information about him and his writings and his life were written by his colleagues. Now, although he lived so many centuries ago and he wrote his teachings so long ago, that doesn't make his concepts irrelevant. A lot of the common math and scientific concepts that we're using today, either in school or in advanced studies, a lot of them were taught and created hundreds of years ago. So these methods are still relevant today, and that's why I'm able to bring these concepts to you today, even though they were written so long ago. All right, now a good starting point to understanding Zeno's paradoxes is to understand why they were written. This is really important because otherwise they just seem like wacky ideas, but Zeno did have a point to what he was doing. So first, his method. He used something called indirect proof, or in Latin, reductio ad absurdum. Note the word absurdum, which we commonly use as the word absurd, which means wild, irrational, etc. So the steps to Zeno's paradoxes are, first, he makes a statement which he opposes. I have to say that he opposes the statement because Zeno doesn't actually believe the world works the way he's arguing. This will make more sense when you see the actual paradoxes, but that's because the original statement seems illogical. It seems untrue. And that's because, in actuality, this first statement is not true. But the point of the paradox is to make us believe that this false statement is actually true. So then he creates a conclusion following this statement that contradicts what we think we know. It makes us question if we really understand the way our world works. And so that's why it's so clever and so fun, because it's really a thinking exercise, a kind of brain teaser to make you question the way you think about things. And so Zeno's actual goals include showing us that our basic common sense and view of reality is absurd sometimes, which is just really clever. He's laughing at us a little bit and making us really question a lot of the way in which we think about things. So, without further ado, Zeno's 3 paradoxes. A lot of them intertwine in certain ways, and bear with me as I explain them. I'll go step by step through each process, and hopefully you're able to follow, Zeno's kind of mindset as he's explaining these paradoxes. So the three include Achilles and the tortoise paradox, the arrow paradox, and the dichotomy paradox. So don't be overwhelmed by the massive amount of text. The Achilles and the tortoise paradox. This is the statement which Zeno originally described it as. So he states that the slower will never be overtaken by the quicker, for that which is pursuing must first reach the point from which that which is fleeing started, so that the slower must always be some distance ahead. What he's saying here is that if you had a slow tortoise and you had a fast man, Achilles, who is strong, fast, fierce, he's a soldier. So the man, Achilles, is obviously moves faster than the tortoise would. But Zeno states that if the tortoise gets any amount of a head start in a race and you send them off on their race, Achilles will never be able to beat the tortoise. Achilles will never even pass the tortoise in the race. It's physically impossible for this trained soldier to run past the tortoise, although he's faster. Now, this is Zeno's statement. So he goes on to explain, well, how we think in the world today. You might say, no, that there's no way. If the tortoise is slower than the man will pass the tortoise at some point. But Zeno goes on to describe and explain using a simple logical procession of facts that no, in fact, logically speaking, Achilles can never pass the tortoise. And here's why. So, a little setup before they start their race. Here's a diagram that shows Achilles, the helmet, starting on the far left side of the segment, and the tortoise running in the race. Before they begin, the tortoise gets that distance of a head start ahead of Achilles. We can call that point A. So the tortoise beginning at point A and Achilles beginning at point O. This gives the tortoise a head start, because we want to be fair to the tortoise, who is obviously slower. And let's say, for the sake of this argument, that Achilles runs exactly twice as fast as the tortoise. So that's our setup. Achilles is able to run twice as fast as the tortoise, and the tortoise gets some amount of head start. This is understandable. And now, here's what happens when they begin their race. So, as you can see, Achilles runs the distance from point O to point A. And in this time that Achilles runs that distance, the tortoise runs some distance as well. So, both are running at their respective speeds, but in the time that it takes Achilles to get to point A, the tortoise has moved some smaller amount of distance from A to B. Now, the tortoise does move some distance, and they both continue to move, and so they don't necessarily stop at points A and B, but we're just looking at an instant of time. So once Achilles has reached point A, he continues running, and so does the tortoise. And so during this next span of time, Achilles runs from point A to point B. And by the time Achilles reaches point B, where the tortoise was, the tortoise has moved forward to point C. So we're basically looking at Achilles and the tortoise's motion in respect to each other, saying that Achilles, as he's moving forward, must always reach the point where the tortoise was at the last time that we looked at them. And so this is where the paradox comes in, because to reach where the tortoise currently is, Achilles first has to reach where the tortoise was. And if this continues accordingly, Achilles can never pass the tortoise, because he can never reach in front of the tortoise. He must first always reach to the point where the tortoise was. And by the time that Achilles reaches the point where the tortoise last was, the tortoise has had the time to move forward. Now, granted, given this explanation, these distances will keep getting smaller and smaller and smaller, but according to this logical procession of facts, everything in this fact list is true. Achilles cannot get to where the tortoise will be before he gets to where the tortoise was. But if this is all true, then Achilles can literally never pass the tortoise. The tortoise will always be some small distance ahead. Now, I'm not going to provide you with the solutions to these concepts because they are incredibly long and incredibly complex. Philosophers and mathematicians like Aristotle have used a various assortment of really long-winded answers and solutions to try to solve Zeno's paradoxes. And people have even used some of Einstein's relative motion ideas and theories to try to solve these paradoxes, because we know there are solutions out there. Because we know that if a tortoise and a man are running in a race, the man will pass the tortoise. We know just from living our daily lives and from our view of reality, we know that the man will pass the tortoise eventually. However, the fun in a paradox is that at first glance, you can't seem to find any holes in Zeno's argument, because we know that the man first has to reach where the tortoise was. And so he cannot pass the tortoise. The next paradox is a little different because it deals with time as opposed to distance. And so the arrow paradox states that if everything is either at rest or moving when it occupies a space equal to itself, while the object moved is always in the instant, a moving arrow is unmoved. In simpler terms, if you are firing an arrow at a target, then you know the arrow travels from the point that you release at the bow to your target, kind of traveling in a line segment almost. However, Zeno will proceed to argue that motion is all an illusion, which is a very complicated topic, but I think it will start to make sense as we go into his explanation, because he says that the arrow can truly never be moved. And here's how he describes this. So for our setup this time, I'm going to describe time as divided into an infinite number of instants. So you can think of time as a line segment, especially the time from when the arrow is fired to when the arrow reaches the target. This is a certain amount of time, however long you want to say. So within this time, this line segment of time is made up of an infinite number of small instances. So you can think of a line and you can think of tiny, tiny dots along that line, and each dot represents an instant. Also in our setup, it states that instants of time are further indivisible. What this means is this infinite number of instants along this line of time. Each of those instants is as small as it gets, a single moment, a single snapshot in time. So these instants that we are looking at cannot be divided any smaller. It's like taking a picture. You could take an infinite number of pictures from when the arrow is fired to when it reaches the target. And when we look at a singular picture, time is frozen. It's simply just that picture. And in that picture, we're looking at a single instant of time, and the arrow is not moving. So here's what happens when we actually fire the arrow. The arrow travels from point A to point B, as previously stated, and they're an infinite number of indivisible instances between those 2 points. Tiny, tiny little dots, instants in time, that are as small as they get in between point A and point B. And so let's examine a single instant, any one of the infinite number between points A and B. For example, if the arrow was traveling and we took a picture of it at any point in between, in that one instant, time will have stopped. It is just one instant. Like taking a picture. You look at it, and in the picture, you wouldn't be able to tell what's moving and what's not, provided that there's no camera blurring with the motion. If it was a steady portrait, it would have appeared that everything is frozen in time because it is just one singular instant. And so in examining this instant, we can say that if time has stopped, the arrow cannot move, and thus the arrow is motionless in that singular instant. Well, the same goes for every other instant that the arrow is flying. So for all those millions and millions, the infinite number of little points in between A and B, in each one, the arrow is motionless. But because this time is only composed of these instants, and within each singular instant, the arrow is not moving, then the arrow doesn't even move in the first instant that the bow is fired. Within each instant, the arrow is not moving. So how can the arrow be considered moving in between A and B? Supposedly, the only reason why the arrow appears to be moving is because the observer is viewing something called the virtue of time. Or as Zeno describes, motion is just an illusion due to time. Zeno argues in this case that motion is possible because we know the arrow moves, but motion is an illusion. It's not real. The only reason why we perceive motion to exist is because time exists. And so through the understanding of time, or through the way that we in reality perceive time, that we think we see motion, but it's really just an illusion. Every motion is really just a combination of singular instants in time where motion is impossible within each instant. So to take a step back into the way that we see the world, we know that motion exists through physics, through, just living our daily lives. We know that things move. We can walk places, we can throw a ball, we can shoot an arrow, and this object will move. Zeno is using this logical procession of facts to say that, well, are we sure? And that's another fun point of the paradoxes, is that he really makes you question if what you're seeing is really happening. And he makes you look at the difference between a logical analysis of a situation and what's actually occurring and what we think is going on. So lastly, we have Zeno's third paradox, called the dichotomy paradox. So in this, Zeno states, there is no motion because that which is moved must arrive at the middle before it arrives at the end, and so on ad infinitum. So in this argument, Zeno states that there is no motion. Yet again, because we'll find out. What does this mean? So here is the setup. To describe this, we have a runner, again, in a race, but trying to get from point A to point B. And when we send him off, here's what happens. So this is similar to Zeno's first paradox in dealing with halfway markers and traveling distances. So in order to reach his endpoint, the man must first get halfway there. We know that. If you are walking across your room, you would first have to reach your nightstand, for example, before you reach the door. You have to cross the halfway point before you make it all the way there. It's a simple fact. However, in order to make it to that halfway point, the man first has to make it to a half of the way there, which is a quarter of the way there. So the man can't reach this halfway point until he first crosses the quarter marker, right? He has to cross these markers in order to get past them. But before he can make it to the quarter mark, he has to make it 1/8 of the way there. And so if this continues, the runner can't ever even start the race, simply because in order to get halfway there, he first has to make it a quarter of the way there. And before that, he has to make it 1/8 of the way there. And before that, he has to make it 1/16 of the way there. And if this continues, the runner can never really even move, because before he moves, he has to make it a half of that distance that he was planning on moving. And so Zeno says that any motion is impossible. This is probably the most grand of Zeno's arguments. And it goes to show that these paradoxes really aren't true, because motion is possible. We know we're able to cross our rooms and walk across the hall. But it's really interesting to see how everything that Zeno states makes sense. You know that you have to make it a quarter of the way there before you make it half of the way there. You know that if you take a picture, it looks like there's nothing moving. And you know that in order for Achilles to make it to where the tortoise is, he first has to make it to where the tortoise was. We know that everything in his arguments are true, which is why it's so interesting that these arguments are leading towards a statement that seems so absurd and impossible. And that's why there are solutions. Now, what solving Zeno's paradoxes does is that someone will state facts that prove the paradox isn't a paradox at all. So they will come up with a hole in his argument where, maybe, at this point, Zeno says something that really isn't true, and here's why. It's providing an alternative argument that kind of reaffirms the way that we see the world. And in solving the paradox, we're kind of brought back to reality, and we should understand better these facts instead of a list of facts leading towards an outcome that seems totally impossible. These lists of facts lead to a solution that does, in fact, make sense in the way that we see the world in our reality. So a solution to Zeno's paradox would lead to us understanding that, yes, motion is possible. Yes, here's why Achilles is able to surpass the tortoise. And so philosophers from Aristotle's time to today have been providing solutions to Zeno's paradoxes. As I mentioned, some of Einstein's concepts of relative theory of motion, these are used in the arrow paradox when dealing with time. However, these solutions get very complex because you can see that Zeno uses our common sense against us. He uses very simple situations, men in races and arrows firing, and he uses small distances like halfway points. All of the math and the concepts in these paradoxes are very simple, which is why it's so convincing and why the paradoxes are so difficult for us, without studying, years and years of mathematics and philosophy. It's why Zeno's paradoxes are so difficult for us to comprehend or to solve on our own, because his concepts are so simple and they appeal to our common sense that everything seems to be true. And so these long-winded solutions would use roundabout ways of describing these situations that are very complex, but end up resulting in an outcome that makes more sense with our reality. I hope the paradoxes weren't too hard to understand, because that was Zeno's point, is they're not too difficult to grasp, but the solutions are difficult to understand, which is why common sense is great when you're going about your daily life and walking to class and doing your homework and, having conversations with your family. But really understanding the way that our world works requires a really intense analysis of time and space and how objects interact. And so he's basically telling us that our common sense does not tell us everything. It just scratches the surface of our understanding of the world. And that's why his paradoxes really affect us this way. So I do have 2 more examples of paradoxes in case the math ones were a little complex. These are more paradoxes based on literature or based on wordplay. And so one of my favorite paradoxes, second to Zeno's, is the 84-year-old who's only had 21 birthdays. Can you think of a reason why someone who has lived 84 years would only have had and celebrated 21 birthdays? It seems impossible, right? Well, I'm going to explain to you this paradox, and then I have a video to go with it. It's actually a song from a musical, so bear with me. I'm a big musical theater fan. But the song, I'm going to describe the situation that occurs in the song. So it's from a musical, and in it, there's a boy who at birth was apprenticed to a band of pirates. And he must serve as a pirate with them until his 21st birthday. That's in his contract. And so he finally, turns 21. He's been alive 21 years, and he thinks that he is done serving. But his birthday is on the 29th of February, which is that extra day that we add on to the month once every 4 years during leap year. That one extra day in February, which actually happened in 2020, is a leap year. And so if he was born on that 29th of February, that means that he only celebrates his birthday once every 4 years. And so by his 21 years on Earth, he has only celebrated 5 birthdays. And he won't be out of his servitude to the pirates by the time until he is nearly 85 years old, because by that time he will have finally celebrated his 21st birthday. So now that you kind of understand this concept, I'm going to show you a video of the song that they sing when the 2 of his pirate comrades, a woman and the dark-haired man, they're both pirates, and they come in to tell him, hey, guess what we just found out? You're not done serving us because you've only had 5 birthdays so far, not 21.
When you had left our parrot fold, we tried to raise our spirits faint according to our custom, with quips and quibbles quaint. But all in vain the quips we heard, we lay and sobbed upon the rocks, until to somebody occurred a startling paradox.
A paradox.
A paradox.
A most ingenious paradox. We've quips and quibbles heard in flux, but not to beat this paradox.
A paradox, a most ingenious paradox. This paradox.
I love a good paradox.
Paradox. For some ridiculous reason, to which, however, I've no desire to be disloyal, some person in authority,
Who?
I don't know who, very likely the astronomer royal, has decided that, although for such a beastly month as February, 28 days as a rule are plenty, 1 year in every 4 his days shall be reckoned as 9 and 20. Through some singular coincidence, I shouldn't be surprised if it were owing to the agency of an ill-natured fairy. You are the victim of this clumsy arrangement, having been born in leap year on the 29th of February. And so, by a simple arithmetical process, you will easily discover that though you've lived 21 years, yet if we go by birthdays, you're only 5 and a little bit over.
Dear me, let's see. Yes, with yours my figures do agree. 5 and a quarter, oh, that's rich. How quaint the ways of paradox, at common sense she gaily mocks. Though counting in the usual way, yes, 21 I've been alive. Yet reckoning by my natal day, I am a little boy of 5.
He's a little boy of 5.
A paradox, a most ingenious paradox. A curious paradox. A most ingenious paradox.
So I hope that made sense. That was the paradox that can be known as the leap year paradox, and that's what happens when someone's born on a leap year on the 29th of February. So that's one of my favorite paradoxes. And one other that has grown increasingly popular in the media is the paradox of Pinocchio's nose. Now this one's a little difficult to describe, so I hope that you take what I have to say and then ponder it on your own, because it's one that you could just think about for hours and hours. So here it is. In the setup, we know that when Pinocchio lies, his nose grows. So what would happen if Pinocchio stated, "My nose will now grow"? Think about that. This statement, what will happen if his nose only grows when he lies? So he says, "My nose will now grow." We don't see anything happening. His nose isn't growing. And so this statement that he says becomes a lie, and his nose starts to grow. But now that his nose is growing, that statement, the original statement, becomes true, because his nose is growing. But now that his statement is a truth, that it was growing, his nose stops growing. So, in this sense, we're not sure whether his nose will grow or not. Because as soon as it starts to grow, the statement becomes true, and his nose has to stop growing. So that's one last non-math paradox for you. And I hope you learned something fun. This is one more example of Zeno's paradox that applies to some of you students today, and that it can feel like we're never going to make it to spring break, or we're never going to make it to the weekend, because before we can make it to the weekend, we have to make it halfway there. We have to make it to Wednesday. But before we can make it to Wednesday, we have to make it to Monday. And before we can make it to the end of Monday, we have to make it until noon that day. And so before we can make it any bit of the time closer towards spring break, it feels like there's always something in front of us and we're just never going to get there. So that's the end of my presentation. I hope that you learned something about paradoxes and how fun they can be. I hope it wasn't too complicated. But I do encourage you, if you're really intrigued in Zeno's concepts, to look him up on the internet, because his paradoxes are some of the most popular in science and in math. As you know, Pinocchio's paradox might be really popular among Disney fans, but throughout history, Zeno's paradoxes have been approached multiple times from many different angles. And so if this is really interesting to you, I encourage you to try to look up some of his solutions and see the different ways that people throughout history have viewed Zeno's paradoxes. And there's also many more paradoxes than just Zeno's, as you saw with the leap year paradox and with Pinocchio. So if this is something that's interesting to you, as it was for me, there's a lot of options out there to really look and challenge yourself to think about these in a different way. And I just love how a paradox really makes you challenge your worldview and makes you question your reality for just a little bit of time. So I hope you feel the same way, and I hope that you learned something new. Thank you for coming and for learning about paradoxes with me. Have a nice rest of your day.